Thanks for the introduction. Very nice and with the light show. So, okay, the slideshow works. Everything's fine. So, before I tell you something about green software, I want to start a little bit broader because everything within sustainability is important to understand in a context, right? But I promise, if you start thinking this is not about software, I promise I will come back to that, right? So I will come to IT, to technology, to software. But before that, I would like to have some feedback from you. So I would like to learn a little bit about you. How did you come over here? Who came with a car? Can somebody? Okay. Did somebody come with a public transportation? Oh, okay, that's good. Did somebody come by walking or bicycle? I'm just bragging, right? Same as you. Okay, perfect. Good. Who of you thinks your form of transportation is sustainable? Yeah. Okay. Good. Okay, perfect. The question is, how do you know? Do you have some measuring points? Did you collect some kind of data? Did you read on this? Okay, let's first talk what is sustainability, and we'll come back to that. So there was an agreement that sustainability, there is even a definition, is not about just CO2 footprint or kind of greenhouse emissions, things like that, because that's mostly what most people think when we talk sustainability. They talk CO2 footprint, but it's mostly that's the planet part. But we need also to talk about people. We need to talk about prosperity. That's about, like, if you talk about these electric cars, you can't just tell to everybody buy an electric car if there are people who can't afford it, right? So that's people and prosperity. And there is also an agreement about what sustainability is, and it's mostly about future generations. So you gain prosperity, you grow, but without affecting the future generations, right? And sustainability is very complex topics, right? And the United Nations agreed on 17 goals around sustainability. Each of these goals have sub-goals, right? So it's very complex. And when we are talking about CO2 footprint, you see climate actions, number 13. You see maybe life below water when you talk about clean rivers. But there is like so many other things, right? Today in the panel discussion, somebody asked whether it is sustainable for companies to strive for profit, for growth. And yes, it is. Innovation and growth is part of the sustainability. We need to think about sustainability also in the terms of growing company, being innovative and kind of improving ourselves. So the first step is to understand this. So why do I talk about this in the software environment or when we are talking about development? Because if you understand what sustainability means, you won't be focusing just on putting your software into cloud and thinking that's it, that's sustainable, that's all I need to do, going into cloud, and then maybe optimizing something. Or maybe I need to change the coding language and then that's it. No, it's much more complex. And you have to think about, like, what other things do I affect by doing some steps which lead me to sustainability. Also, I hear a lot of, you maybe heard the word greenwashing, right? And after kind of going through this, and this is my belief, I don't have an official definition or something like that, but if one company picks one of these things and labels, like, we are doing this as sustainable activity, and then promotes it, that means, and they do nothing else, that's, in my opinion, that's greenwashing. But if you want to really be sustainable, you go through all those areas and you see where I'm not sustainable yet, where do I need to change? And that's where you come into play as software developers, as IT guys, IT people, to find a way how to help yourself, people, customers, and big companies to be sustainable, right? So what we do at Accenture, it's one of the initiatives, like when we deliver projects, as an example, like how do we measure this? Or how do we go through this? One of the applications is called Project Green Quotient, which looks at how we deliver projects, right? And we look at 4 different areas. It's technology, metrics, team, and processes. So first of all, we look at like what technology are we using? Are we using cloud? Are we using which database are we using? Which software language and so on? Then we look at metrics, like what are we measuring actually? Do we know actually how much power we consume or what is our CO2 footprint? In the area of team, is our team knowledgeable? Do they know what they need to do? Do they know how they should improve their for example, commuting to the office? How does that affect the overall sustainability of the development? And then processes. Do we have implemented processes which help us be more sustainable? And we do this assessment. We go across the project. We ask questions. We get some feedback from that. And out of that, we get a score, which is something, right? And then we look at the score and we look at the areas and look for improvements, right? So, for example, this is an example dashboard for a group of teams, and we find out the overall score is 0.4. What we strive to do is, like, in the next half year, we want to have a better score, right? And we have, what is important, we have like very concrete suggestions on how to improve, right? So we should, for example, compress the data before sending them to the network because it consumes bandwidth, it consumes electricity, and so on, right? In the measuring area, we suggest to the project go and start measuring your electricity bill, right? Or consumption of the electricity or the carbon footprint. Also, another suggestion in the area of people, we suggest let's teach the people, like what it means sustainability. We have a very good program at Accenture called Sustainability Quotient, where we strive to, where we give the opportunity to everybody to understand sustainability. What is it? What are the kind of supply chains management? What is the CO2 footprint? What is diversity and inclusion? How does that affect sustainability? And of course, we suggest to improve some processes. And when we have that, when the people understand what sustainability is, they can come themselves with their own ideas how to improve the project or how to develop new products for the customers. So either to develop a green software or a software which enables sustainability for the clients, for ourselves, right? And one such example is something we want to show you today, and will be shown by Peter, is about how you can, and this is a software which can help you to decide the right software language and the database. So with that, I'm giving over to Peter Antal with his software.
Thank you all for coming to this very late presentation. In 2022, this year, European Union proclaimed electricity from gas as green. So now if you order green electricity at your provider, you will get electricity from gas. So that's one of the top-down solutions that we got. But what about bottom-up solutions? Do we, common developers, you and me, have any ways to drastically decrease CO2 emissions? It turns out we can, and we have some of the most efficient solutions there are. A bit about me. I am technology architect at Accenture, and I think that's enough for now. So we'll go through these topics. First, a little more intro, then formulas, how to calculate carbon footprint, how much does software produce, how much CO2 does software produce. Then we'll have some examples with WordPress on AWS. I chose WordPress because it's very common, everyone knows it. And in the end, we will see the other ways to optimize the software to be more green. Now, why green everything? We all know the current green trend. Green cars, green electricity, green buildings, green everything. And it's here because of international commitment in Kyoto Protocol to reduce carbon emissions to 0 until 2050. And that's only the first step. We actually need negative carbon emissions. So that's the final goal. So this green trend will likely stay around until 2050 at least. Various industries produce CO2 in various ways. For instance, when manufacturing concrete, CO2 is produced by burning limestone. In our field, in IT, we produce CO2 by requiring electricity that is made by burning fossil fuels. There are also other ways to create electricity, hydro, nuclear, etc. But these other means cannot be regulated that easily. And if we cannot regulate electricity production quickly, we will either have surpluses or we will have deficits. And deficits are bad because obviously we don't have electricity, we cannot run our software. But surpluses are also bad because they damage power lines, lights, and devices and everything. So we cannot get rid of fossil fuels entirely, but that's where carbon capture technology comes into play. But these technologies also cannot capture huge amounts of CO2. If you wanted to go the old way and plant trees, we would need to cover about 10% of Earth's surface with trees, which is about North and South America combined. And there already are trees, so we really don't have much space to plant them. So, how much electricity does software consume? We know that software consumes some electricity. The more it is running, the more electricity it produces. But until we see the real data, we don't care too much. But looking into real data is mind-blowing. What if I told you that just by making one simple decision, we can decrease CO2 emissions by almost 70%, and in some cases even more? We will get back to that later in this presentation. Oh, I have this. So, with software and PCs, it's like Gabe Newell said, PC has always had a huge amount of scalability. It was sort of the wild dog that moved into Australia and killed all the local life because it could just adapt. So, are we creating Avatar world or Mad Max world? We will see later. First, a little bit about history and how we got where we are. In the beginning of the computer age, computers were slow and inefficient. But since they were slow and inefficient, developers were trying to make software as efficient as possible. And there were techniques like placing, back then when there were disk memories, like placing data in specific parts of the disk and even instructions, so that later when the disk was spinning and the instruction was needed, it was just arriving at the read head and not a microseconds was wasted. And we consider this today extremely nerdy, but techniques like this were common practice back then. And even now, in some areas of software development, optimization is a huge part of development. For instance, in database development or 3D graphics. But in the areas where the most developers work on, like web development, etc., we very rarely see optimizations these days. And the reason is that we have enough cheap computing power. And more important is the ability for multiple people to work on the same software more efficiently. We basically traded off performance for readability and maintainability because that was the previous trend. And there's nothing wrong with that. but the new trend is green, and it's coming to our industry as well. So we cannot actually measure how performant software is, but we can measure how much electricity it consumes, and therefore how much CO2 is produced. And we basically want carbon footprint. And carbon footprint of entire software lifetime consists of carbon footprint of analysis, of design, of development, of testing, of delivery, of runtime, and of maintenance. And that's quite a lot of things to consider. So in this presentation, we will focus on carbon footprint of development and on runtime. This is the basic formula that is used to calculate carbon footprint. P is power consumption in kilowatts, T is time in hours, and F is emission density factor. And for EU, the average value is 0.5 kilograms per kilowatt hour. Average for the world is about 0.5 kilograms. The best country, each country has different number of this emission density factor, and the best country is Iceland. And since they spun up their carbon capture plants, they actually have negative emission density factor. The worst is South Africa with about 0.93. So, for instance, let's say we have a 1000 watt appliance, so like a basic small heater or something, and it's running for 1 hour times the emission density factor, and the result is 0.25 kilograms of CO2 while running this appliance. How much is 0.25 kilograms? 1 kilogram of CO2 under normal condition takes up about 1 cubic kilometer of air under normal conditions. Now let's get to the examples. We will have one example with WordPress. It will be running on AWS, on EC2, and database will be RDS. Let's say we will have 100 visits per day, and the WordPress will be taking 100 megabytes of disk space and 10 megabytes of database. So this is something like a small e-shop with 30 items. And on WordPress, or on average website, one visit takes about 5 requests. And one request in WordPress is about database queries. We need these numbers to have something to plug into the formula. So on the AWS, we will use this T3 micro instance, which is like the smallest useful instance for this particular case. It has 2 virtual CPUs, 1 gigabyte of RAM, and actually these numbers are very hard to find. The idle power consumption for this machine is 4 watts. Maximum power is about 11 something, but we'll actually use 80% power consumption because that's more realistic, and that's 10 watts. RAM or memory, 1 gigabyte consumes about 0.41 watts, and that's constant throughout the day. For database, AWS has the same instance. And one more thing to calculate or to get is time spent. So 600 milliseconds virtual CPU time per request, that's measured for WordPress, that's average. So if we have 5 requests, that's 3 seconds per 1 visit. And if we have 100 users per day, that's 300 seconds of virtual CPU time per day. For database, one page load takes up about 10 queries. One query takes about 10 milliseconds, so 100 milliseconds per page load. And 500 milliseconds of virtual CPU time per visit. We have 100 visitors, so 50 seconds of virtual CPU time of database per one visit. Now we have everything we need. We can plug the numbers into the formula. Now I know this looks horrible, but it's actually still the same formula. Carbon foot, the emission density factor is the same. P times T, power times the time, has multiple items. So it consists of EC2 work time times EC2 power consumption at 80%, plus EC2 idle time times EC2 idle consumption. The same for database, and plus memory. We plug in the numbers and we get the number carbon footprint 0.053 kilograms per 1 day. Now, is it a lot? Is it too little? What if this instance was completely idle? It was just running and it didn't serve any user. In this case, the formula is simpler because we leave out the consumption at 80%, and we get number 0.0529 kilograms, which is almost the same number. So the machine is idle, and then we add 100 users, and carbon footprint almost doesn't change. Now, what about if the WordPress was running all day non-stop at 80%? How much users would we be able to serve, and how much CO2 would be produced? So, if we have 3 seconds virtual CPU time per visit, it means about 28,800 visits per 1 day. And again, we plug in the numbers to the formula, and we get number of 0.095 kilograms of CO2 per 1 day, which is not even double of the original number. So we have a machine that serves 100 users, and it produces some emissions. We add 288 times more visitors, and the emissions doesn't even double. So what does it mean? It means keep your devices busy or turn them off. And that's basically virtualization in a nutshell. Virtualization, what it does for us is it takes applications from many machines and puts them on the least amount of machines possible and turns off all the other machines. Now let's put these numbers into context with something we know very well. So I chose some numbers of cars and smartphone. So for light commercial vehicles, the carbon emissions are about 0.175 kilograms per 1 kilometer. For newly registered passenger cars, it's even less. Hybrid electric cars, even less. Almost half of light commercial vehicles. Tesla Model S for 1 kilometer is 0.04 kilograms. And smartphone, one charging of smartphone with basic 4,000 milliampere hour battery is about this much. Now let's put the WordPress numbers here. So fully utilized WordPress produces as much CO2 as hybrid car running for 1 kilometer. Fully idle WordPress produces, well, half of it. Now, this is all in case WordPress is running in PHP, which it does. Now, what if WordPress was written in different programming language? For instance, Python or Java or JavaScript or C or whatever. How much CO2 would it produce? We have numbers for that, and it's available on the internet. So this is where it becomes an estimation. Until this point, it was measurement and calculations. Here it becomes estimations. And this is development time. If the application of the size and complexity of WordPress was developed in these languages, the CO2 production during development would be this. So the worst one would be C, then Pascal, JavaScript about half as much. Then somewhere in the middle we have all the other languages, Ruby, C#, Python, PHP, what else? Ruby, Rust, Erlang. And the best would be Delphi, Perl, and Haskell. Now this is development. Before we had runtime. Now let's put these numbers together. And let's do it this way. Let's make your bets. Which language will win? And in 3 seconds, I will switch this slide. So it's starting. The starting line at 0 is the same alignment as it was on the slide before. So we can immediately see that some languages grow rapidly, some grow just a little bit. Now, after serving 5 million of users, combined emissions of development and runtime of Python, Perl, and Ruby is more than combined emissions of C. And after 10 million of users served, it looks like this. The worst is Python, Perl, Ruby. These are the most producing languages. And then somewhere in the middle, or the middle of this graph, we have PHP, C, and JavaScript on backend. So this is actually Node.js. And the best one is Delphi. Turns out to be. If we go back to the WordPress example that we had before, in the beginning, we had WordPress that serves 100 users per day. So 100 users per day, if it's running for 1 year, it's about 36,500 users. Let's say it's running for 5 years. So it's about 180, 190,000, let's say 200,000 users. We are still here in the beginning. So for small applications or applications that are not expected to serve many users, we are looking here. The more users or more load we expect, the more we are looking here. Now these are all backend technologies. What about front-end technologies? This slide may be dismal to look at because we use React, which turns out to be the most producing technology we've ever had. Then other JavaScript frameworks are around the same producers, Vue, Angular, and jQuery, and vanilla JavaScript. Then there is PHP for reference. It's the same line with the same inclination. And fortunately, we have this new emerging technology called WebAssembly. And in that case, if we develop application running in WebAssembly, the best one would be Delphi, Haskell, Rust, C#, C++, Java, C#, and so on. Now, who wants to be Delphi developer? Right, no one. We cannot use technology just because it's green if we don't have people who are experienced in it, or even want to be working with it. What's next? Haskell. Haskell, anyone? Also no one. Then Rust. According to Stack Overflow research, 86.73 people who ever tried it love it. And 17.6 people, 6% of people want to be working with it. So Rust seems to be very green. Cloud providers support it. Developers love it. So it seems like cure for everything. So are we developing Avatar world or Mad Max world? It seems like we are developing Mad Max world, according to the previous slides. Now, green software is not just producing less CO2. It's also faster, more exciting, and cheaper. Because for instance, in cloud providers, we are paying for milliseconds or microseconds while the application is running. So if we decrease microseconds, we also decrease the money spent. So by switching from JavaScript to Rust, we can save about 67% of money. By switching from Python to Rust, we can save 70% of money for running the application. We could see that some languages have more efficient development time, some have more efficient runtime, some have both, and some have neither. And these days, we use languages that have neither development time and neither development efficient runtime. And why? Because they are simple. Anyone can do 2-hour React or Python course somewhere on Udemy or FreeCodeCamp or wherever, and can already create a simple website. And in these times when there is such a lack of developers, this is actually the approach we want. But with the first lines of code in inefficient language, developers should start looking into more efficient languages. So these are the other options we have to optimize our software to be more green. Choose the right instance type and use auto-scaling if possible. Keep it simple. Also, don't reinvent the wheel. If you can use something that was already created, use it. Then use virtualization, cloud, and serverless. Now, these three, we all know very well, but we keep forgetting it these days. Optimize your code, optimize your database, optimize network traffic. And in the end, the rule of thumb is that compiled languages are greener than virtualized languages, and they are greener than interpreted languages. And in the end, if you could take only one thing from this presentation, because there was a lot of numbers, take that. Just by switching to Rust or WebAssembly, we can save about 70% of CO2 emissions. Now, I will end this presentation with that. And if you have any questions, let's get to them now.
Thank you so much. We have questions from Delphi. Delphi wants to know. If you have a question, we have 3-4 minutes left. So if you want to ask anything about sustainability, do it now. And if you're like Marnik, it has been a long day. We're ready for the lottery. We just want to get some drinks and some hot dogs, apparently, in the tent. We have a question.
Why is Delphi not live? Is it so complicated? Is it rude? What about Delphi?
It's considered to be old because many people were learning it in the high school, and the idea is that it's for children to learn programming and stuff like that. Many people use it, and who uses it actually loves it. But it's most usually the old people, older people, 50, 60.
All right, any more questions? Okay, I think we're good. Then give him a big round of applause. Richard, wherever he sits, and Peter, thank you so much. Thank you.